Hello everyone, and welcome back to the channel. Today, we are going to explore one of the most extreme engineering ideas ever imagined. An airport built on the very top of a mountain. Not beside a mountain, not near a mountain, but directly on the summit where the air is thin, the slopes are dangerous, the weather changes in minutes, and every meter of land has to be carved, reinforced, and controlled with absolute precision. Before we begin, make sure to subscribe to the channel, hit the like button, and follow us for more incredible construction stories, mega projects, and impossible engineering challenges from around the world. Now, let's begin the journey of building the airport on the mountaintop. Imagine standing on a remote mountain range, thousands of meters above sea level. Around you, there are sharp cliffs, deep valleys, unstable rock faces, powerful winds, and clouds moving below your feet. It is a place where even building a road is difficult. Now imagine someone says, "Let's build a full airport here." At first, it sounds impossible. An airport needs flat land. It needs long runways, strong foundations, wide taxiways, terminal buildings, fuel systems, radar equipment, emergency roads, drainage systems, and enough space for aircraft to move safely. But a mountaintop gives you almost none of that. There is no flat surface. There is limited access. There is dangerous terrain. There is extreme weather. There is less oxygen for workers and machines. And every construction mistake could trigger landslides, rockfall, or structural failure. That is why this project is not just about building an airport. It is about reshaping a mountain. The first stage begins long before any concrete is poured. Engineers arrive with survey teams, drones, helicopters, geological equipment, and satellite mapping systems. Their first mission is to understand the mountain itself. They study the rock layers, the fault lines, the slope angles, the wind patterns, the snowfall, the rainfall, and the natural drainage paths. They need to know which parts of the mountain are strong enough to support heavy aircraft, and which parts could collapse under pressure. This stage may look quiet, but it is one of the most important phases of the entire project. Because if the mountain is misunderstood, the airport can never be safe. Engineers mark the future runway alignment, locate the terminal zone, plan the access roads, and identify where massive retaining walls will be needed. They also calculate how much of the summit must be cut away and how much material must be used to fill the valleys. The goal is simple but brutal. Create a flat, stable airfield platform where nature never intended one to exist. Then, the real transformation begins. Heavy excavators, drilling rigs, bulldozers, dump trucks, cranes, and blasting teams move onto the mountain. Temporary roads are built along steep slopes, allowing machines to climb higher and higher toward the summit. At this point, the mountain becomes a construction battlefield. Rock faces are drilled. Controlled blasting breaks massive sections of stone. Excavators remove broken material. Dump trucks carry rock to low areas that must be filled. Bulldozers spread the material layer by layer. Compactors crush it into a dense, stable platform. This is not random earth moving. Every cut and every fill must follow a strict engineering plan. If too much rock is removed from one side, the slope may become unstable. If the fill is not compacted properly, the future runway could sink, crack, or deform. So, the mountain is shaped slowly, carefully, and repeatedly checked by survey teams. Day after day, the rough summit begins to change. Sharp ridges become terraces. Steep cliffs become reinforced slopes. Uneven ground becomes a massive artificial plateau. And for the first time, the shape of an airport begins to appear above the clouds. But flattening the mountain is only the beginning. A mountaintop airport faces one major enemy: gravity. Everything wants to slide downward: soil, water, snow, rocks, and even the platform itself if it is not properly supported. That is why engineers build huge retaining systems around the edge of the airport. These are not small walls. They are enormous reinforced concrete structures, anchored deep into the mountain rock. Steel reinforcement cages are placed inside formwork. Concrete is poured in sections. Rock anchors are drilled into the mountain. Drainage pipes are installed behind the walls to release water pressure. Protective barriers are added to stop falling rocks. These retaining walls become the hidden backbone of the airport. They hold the mountain in place. Without them, the runway would not be a runway. It would be a disaster waiting to happen. At the same time, slope stabilization teams cover exposed rock faces with steel mesh, shotcrete, drainage channels, and anchor bolts. The goal is to lock the terrain together like a giant engineered shell. This is where the project becomes more than construction. It becomes a fight against the mountain's natural forces. Next comes one of the most important parts of any airport: the runway. On a normal flat plane, runway construction is already complex. But on a mountaintop, it becomes a precision operation. The runway must be perfectly aligned, properly sloped for drainage, strong enough to support aircraft loads, and long enough for safe takeoff and landing in thin mountain air. At high altitude, aircraft engines produce less power, and wings generate less lift. This means planes may need longer takeoff distances compared to airports at sea level. So engineers cannot simply build a short strip and hope it works. They must design the runway with extreme care. The foundation is built in many layers. First comes the stabilized ground, then a subbase layer, then crushed stone, then asphalt or concrete pavement, depending on the design. Each layer is tested for density, strength, and smoothness. Special drainage channels are built along the runway edges because water on a mountaintop can be deadly. Heavy rain or melting snow must be removed quickly before it weakens the pavement or freezes into ice. Runway lights, centerline markings, edge lights, approach lighting, and navigation systems are installed with high accuracy. The final surface must look simple, but underneath, it is a carefully engineered structure designed to resist weather, weight, vibration, and time. While the runway takes shape, another critical part rises nearby: the terminal. The terminal of a mountaintop airport is not just a passenger building. It is a survival structure. It must handle strong winds, heavy snow, temperature changes, and limited space. It must connect to roads, parking, baggage systems, security areas, emergency services, and aircraft gates, all within a narrow mountain platform. Engineers may build the terminal into the slope, partly protected by the mountain itself. The structure uses strong foundations, steel frames, reinforced concrete cores, and wide glass surfaces designed to resist wind pressure. Inside, passengers may experience something extraordinary: a modern airport hall with panoramic views over valleys, clouds, and distant peaks. But behind that beauty, the building is full of technical systems: heating, ventilation, fire safety, emergency power, baggage handling, communication rooms, snow control systems, fuel safety zones, aircraft support facilities. Every system must work reliably, because on a mountaintop, failure is harder to repair. This is not only an airport terminal. It is a high-altitude control center. One of the most dramatic challenges is access. How do passengers, workers, fuel trucks, emergency vehicles, and supplies reach an airport on the summit? The answer is another massive construction project: mountain access infrastructure. Engineers build winding access roads, tunnels, viaducts, switchbacks, service roads, and emergency routes. Some sections may require bridges across deep ravines. Others may require tunnels through rock shoulders. Avalanche barriers, retaining walls, drainage culverts, and guardrails are installed along the way. The road itself must be safe in rain, fog, ice, and snow. And because airports operate every day, the access route cannot be fragile. It must support continuous traffic, heavy vehicles, and emergency response. This means the airport is not just built on the mountaintop. The entire mountain is redesigned to serve it, from the base to the summit. Every road, wall, tunnel, and drainage line becomes part of the airport system. Then comes the airside infrastructure. Taxiways connect the runway to the apron. The apron is built strong enough to hold parked aircraft, ground vehicles, and fuel trucks. Aircraft stands are marked. Jet bridges or mobile stairs are installed. Service roads are arranged so vehicles can move without interfering with aircraft. Fuel storage must be carefully located and protected. Fire stations must be close enough to respond quickly. Rescue vehicles must be able to reach any part of the runway within strict emergency time limits. Air traffic control systems are installed to handle the unique mountain environment. Radar, weather stations, communication antennas, wind sensors, and approach guidance systems are placed in strategic positions. At a mountain airport, weather is not just background information. It controls everything. Fog can appear suddenly. Crosswinds can become dangerous. Clouds can cover the runway. Snow can block operations. Ice can form on pavement. Visibility can disappear in minutes. So the airport needs advanced monitoring, fast response teams, and constant maintenance. This is where the project becomes fully alive. Finally, after years of construction, testing begins. The runway is inspected. The pavement is scanned. The lights are tested at night. Drainage is checked under heavy water flow. Emergency vehicles run response drills. The terminal systems are tested. Navigation equipment is calibrated. Trial vehicles move across the apron. And finally, test aircraft approach the mountain. This is the moment every engineer has been waiting for. From the air, the airport looks unreal. A long, flat runway placed across a mountain summit, surrounded by cliffs and clouds. The first landing is not just a flight. It is proof that the impossible has become real. Wheels touch the runway. The aircraft slows down. Emergency teams stand ready. Engineers watch every detail, and the mountaintop airport receives its first plane. A place once ruled only by rock, wind, and sky has become a gateway for people, trade, tourism, and connection. But why build an airport in such a difficult place? The answer depends on the region. For remote mountain communities, it can reduce travel time from days to hours. It can connect isolated areas to hospitals, markets, education, tourism, and emergency services. It can support rescue missions, disaster response, and regional development. For tourism, it can transform a remote mountain region into an international destination. Hotels, roads, services, and local businesses can grow around the new connection. For engineering, it proves something even bigger. Humanity can adapt infrastructure to some of the most extreme landscapes on Earth. But this kind of project also demands responsibility. A mountaintop airport must be designed with environmental protection, slope safety, water management, and long-term maintenance in mind. The mountain cannot be treated as empty land. It is a living landscape with ecosystems, water flows, and natural risks. The success of the project depends not only on how spectacular it looks, but on how safely and intelligently it is built. The airport on the mountaintop is more than a runway in the clouds. It is a story of courage, risk, technology, and precision. It begins with a wild mountain summit, where construction seems impossible. It continues through blasting, excavation, retaining walls, drainage systems, runway paving, terminal construction, access roads, aviation systems, and endless safety testing. Every machine on that mountain fights gravity. Every wall holds back pressure. Every drainage pipe protects the runway. Every layer of pavement carries the weight of aircraft. Every light guides pilots through one of the most challenging environments on Earth. And when the first plane finally lands, it marks the victory of engineering over terrain, not by destroying nature blindly, but by understanding it, shaping it, reinforcing it, and respecting its power. This is why mountaintop airports capture our imagination. They remind us that the most impossible places often produce the most unforgettable engineering stories. Thank you for watching. If you enjoyed this journey into the construction of the airport on the mountaintop, don't forget to like this video, subscribe to the channel, and follow us for more incredible mega projects. Impossible airports, bridges, tunnels, dams, and engineering wonders. Tell us in the comments, would you dare to land at an airport built above the clouds? See you in the next video.